Okay, so let's take a look at our schedule. We're going to talk about transformations of functions today. This is section 2.5 out of your textbook. We're going to talk about 2.5 for 3 full classes. Okay, so you may not feel entirely comfortable with the 2.5 material until we finished all 3 classes. Okay, and much of the work you're going to be doing in these is individual activities, sort of discovering the rules of how this works. So again, you might feel like you don't know what you're doing until you come to the end of a lesson when it's like sort of gets summarized. But know that it is leading you somewhere and it will make sense at the end. And what else do I want to tell you about how we're doing this? Your next project, project 2, is on transformations of functions. So I want to get us at least through 2 of the lessons, and then I'll give you the project. So I'll give you the project like Monday. So no, Friday. I'll give you the project next class for you to get started to work on that. Okay, so everybody looks pretty okay with the preview exercises. So I'm just going to jump to the demo here. So if you want to graph f of x equals x squared by hand, then if you don't know what it looks like off the top of your head, you would just plot some points, right? You can just make a little f of x chart. We used to call this an xy chart, but now we're using f of x because we're advanced algebra students. Okay, so just pick a bunch of x's, and you get the y values by plugging into your formula, so you square them, so you get 9, 4, 1, 0, 1, 4, 9, and we plot this. -3, 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, 3, 9. We'll connect them with a nice smooth curve. Okay. So now I want to graph each of these guys on a calculator and copy them to the graph that I just drew, so on the same set of axes. If you have different colored pens and pencils, that would be helpful, but it's not that big a deal as long as you label everything. I'll use my graphing calculator here, and I have some graphing calculators to give out so that you can follow along. Let me just grab those. Okay, so we haven't used graphing calculators for quite a while. You each have one now, and I'm just going to use them for some of their most basic functions. I want to take a formula and create a graph. So my first graph, g of x equals x squared plus 3. G of x is just a fancy way of saying y. So if I want to graph this thing, I press the y equals button. If there's anything in there, I clear it. Just press clear. Make sure this whole screen is blank. And type in x squared plus 3. Okay. So x is second column, 3 down in the second column. And to raise things to a power, use the little caret. So you got x squared plus 3. And then a shortcut for a good window is zoom 6. And if I want some values, if I wanted to know exactly where those points are, I could go to my table. So you hit second graph, and you go to your table, and then you can type in any x value you want, and it'll tell you the y value. So maybe I'll do like -3, -2, -1, 0, 1, 2, and 3. The same x values I did when I plotted by hand. All right, so I'm gonna sketch this in a different color. So I have -3, 12, -2, 7, -1, 4, 0, 3, 1, 4, 2, 7, and 3, 12. And I'm going to connect those with a nice smooth curve. All right, so that in pink, that's g of x equals x squared plus 3. The purple one was the original f of x equals x squared. And then if I want to graph x squared minus 4, any conjectures about what it's going to look like? Any guesses? It's going to translate 4 units down. Yeah. Let's just verify that on our calculator. So I go to y equals, instead of x squared plus 3, I want minus 4. And I graph it, and you can see it did move down. And if you want to be really exact about your points, you can go to your table. You just hit second graph, and you get a table of values, x's and y's, that you can copy or that you can plot. So I have negative 3, 5, negative 2, 0, negative 1, negative 3, 0, negative 4, 1, negative 3, 2, 0, and 3, 5. Connect those. And that is h of x equals x squared minus 4. So you have 3 functions graphed here. In your own words, we want to describe what has happened to the original graph f of x, the purple graph, right, to get each of the new graphs. Has the graph been moved left or right, or up or down? Okay. So to get the graph of g of x, the graph of f of x shifted up 3 units. Right? To get from the purple graph to the pink graph, you just take the purple graph and move it up 3. And then to get the graph of h of x, starting from f of x, so starting from the purple graph to make the green graph, you just take every point on the purple graph and move it down 4 units. So to get the graph of h of x, the graph of f of x shifted, I'm just going to do this in green so it matches, shifted down 4 units. All right, so for each of my formulas, I want to calculate f of 0, g of 0, and h of 0. So remember, f of x is x squared. G of x is x squared plus 3. And h of x is x squared minus 4. So for evaluating f of 0, g of 0, and h of 0, that 0, what variable does that represent? What am I plugging 0 in for? X. Good. So if I plug a 0 into the f formula, you just get 0 squared, which is 0. If you plug a 0 into the x squared plus 3 formula, you get 3. And if you plug 0 into x squared minus 4, you get negative 4. So you can see to get from f to g, you add 3. To get from f to h, we're always subtracting 4. And then let's just do one more for practice. If I want to plug negative 2 into the formula for f, what is negative 2 squared? 4. Now plug negative 2 into the g formula, so you get negative 2 squared plus 3, which is 7. And then plug a negative 2 into h's formula, 0. So again, to get the y value from f to the y value of g, you're adding 3. The y value of f to the y value of h, you're subtracting 4. All right, let's think about the domain and range of f, g, and h. So the domain of f, that's the purple graph, or f of x equals x squared. What x values make sense for x squared? Negative infinity to infinity. You can square anything. There are no restrictions. Okay. And then what's the range for x squared? What's the smallest value you can get when you square something? 0. And what's the largest value? Infinity, yep. How about G? Let's look at it. Let's just look at its graph and try to do this one from its graph. So the domain of G, so looking at the pink graph here, what x values does this guy live on? All of them. Good, so negative infinity to infinity. And then its range, though, is the smallest y to the largest y. What's the smallest y on the pink graph? 3. So we go 3 to infinity for the range. Okay. And then the green graph is also negative infinity to infinity for its domain. But what's its range? What's its smallest y value? Negative 4. Did the transformation that we do change the domains at all? No, the domains are all negative infinity to infinity, right? So the fact that I had x squared plus 3, and x squared minus 4, they all had the same domain, so no changes, right? But look at the ranges. Did the ranges change? Yes. Okay. And range describes y values. Okay. So what we did was we created a vertical change in the graph, and vertical changes in the xy plane are described by y values. And the range has changed, which is a description of y values. So I want to rewrite g and h as transformations of f. Remember, f of x equals x squared. That's my original function, f of x equals x squared. The transformation that we did happened after the squaring. So I have x squared and then plus 3. So we call that post-operation. This changes only the output and represents a vertical transformation. Okay. So let's see. If x squared and f of x are equal, right, then anywhere I see an x squared, I could replace it with f of x. They're equal. Okay, so g of x is equal to f of x plus 3. And h of x, instead of writing it as x squared minus 4, which is how I gave it to you, you could rewrite that as f of x minus 4. Okay, because x squared and f of x are equal to each other, so you can make that substitution. All right, so f of x is just a fancy way of writing y, right? And g of x is just a fancy way of writing y. So g of x is the old y value plus 3. H of x is the old y value minus 4. All right, so that means that if I want to write down some points on g, I need some points on f, and I can figure out the corresponding points on g. Right, so negative 2, 4 was a point on f. Corresponding point on g, just have to add 3 to the y value according to this rule right here. Add 3 to the y value. So that becomes negative 2, 7. Right, and then negative 1, 1 becomes negative 1, 4. And then I have 0, 3, and 1, 4, and 2, 7. And those were already points that my graphing calculator had given us, but now we could just look at the formula and be able to come up with those in our head. Okay, so we've discussed one kind of transformation together, right? This is a vertical shift. We call this a vertical shift. I'm going to have you look at another vertical shift at the start of your class activities, and then you're also going to investigate some horizontal shifting. So the rest of the activities you're going to be working through on your own, and I will come around and help. If you don't finish, you really need to finish the activities from this class and the next 2 classes at home if you don't finish them in class, because you will not have the conclusions to be able to do your homework unless you do all the activities. right? Because I didn't do everything in the demo that you need to know.